So in this video, we are going to review function composition, and then we are going to explore more into making sure that you can correctly name the domain and range of a composed function if each original function has a restricted domain. So first, let's review function composition. So function composition is when you evaluate one function based on the results of another. So you're used to seeing something like this, f of g of x, or when you see that symbol, it means the same thing. It looks like fog, but that is the operator that is letting you know you're dealing with function composition. So when you say f of g of x, okay, what this is saying is g of x, whatever you get when you stick x into g, okay, so g of x is output, g of x is the input of f. So you're going to stick numbers into g, then you get the output, g of x. Those output values are what you plug into f. So let's go over an example. If we have f of x equals the square root of x plus 1, and we have g of x equals x plus 4, and the first thing I ask is, let's find f of g of x and state the domain and the range of the newly composed function. So f of g of x is going to be a new function. What you have to keep in mind when you state the domain is you can only plug in numbers that are going to output real numbers. So when we do f of g of x, when we make our new function, we have to stick function g into f. So if this just said f of triangle, this would be the square root of triangle plus 1. But triangle is function g. So f of g of x is going to be the square root of x plus 4 plus 1. That's going to be the square root of x plus 4 plus 1. That's going to be the square root of x plus 5. So that's your newly composed function, the square root of x plus 5. Now, when you check for domain restrictions, the first place you check is where are x's first going to filter through? They're first going to filter through g. So are there any restrictions to x plus 4, domain restrictions? Any domain restrictions? None. Okay, so the first place you check is the inside function. No domain restrictions. Now, you never really have f. Your new function, notice, nowhere do you have x, the square root of x plus 1. What you now have is the square root of x plus 5. So will we have domain restrictions? Yes, because we can't take the square root of a negative number. So we're concerned with making sure that that radicand x plus 5 is greater than or equal to 0. So the domain is x is greater than or equal to 5. If we write this interval notation, smallest number could be as -5, largest number could be as infinity, and f of g of x is the square root of x plus 5. Okay, number 2, why don't we do g of f of x? Okay, state, domain, and range. So does order matter in function composition? Let's check it out. So this says the input of g is going to be f. So we have to stick f into g everywhere there's an x. So that's going to be g of f of x is going to be the square root of x plus 1 plus 4. We just plugged in f everywhere there was an x in g. Now, only a 1 outside this parenthesis, so this is just going to be the square root of x plus 1 plus 4. And now that is our newly composed function. There's nothing left to simplify there. Now we need to state the domain. So you first look at the domain of the inner. That's where your x's first filter through. The square root of x plus 1 that's got a domain of x is greater than or equal to -1. Now, we check our newly composed function to see if it created any new domain restrictions. It did not, so this is our domain. Now, what I forgot to do was state the range of number 1, so that's the domain. The range, this is a square root. The first number you can plug in is -5. As you plug in numbers greater than -5, we're just going to be taking the square root of real numbers. So this is going to be, the first number we're going to get is 0 as an output, then everything above 0. So y is greater than or equal to 0, or 0 comma infinity. This one, our range, first number we'd be allowed to plug in is -1. -1 plus 1, 0. Square root of 0, 0. 0 plus 4, 4. And then this is a square root. Are we going to be growing in values from 4 or shrinking? Since there's no negative outside the square root, we're just going to be getting larger. So this is going to be y is greater than or equal to 4. Okay, so let's practice a bit more. Why don't we come up with some new, I'm going to write down some new functions here. So let's write f of x is 1 over x. G of x is the square root of x minus 1. And h of x is x squared plus 5x. And m of x is 2x plus 1, number 1. Let's evaluate h of m of x and state the domain of the result, which is your newly composed function. So let's do that. So h of m of x means we're going to take m and stick it into h. H has two x's, an input here, an input here. Okay, so we have to stick m into h everywhere there's an x. So it's going to look something like this. Wherever there was an x and h, we have to stick m. So you got to be careful here. This is one of those most common mistakes in algebra. You have a binomial squared. To expand it, we do not have a property of exponent. We have how we simplify. Okay, 10x plus 5. It's going to be 4x squared plus 2x plus 2x plus 1. That's going to give us 4x squared, 2x, 2x, 10x. That's going to give us 14x. Plus 1, plus 5, plus 6. And now we have to state the domain of this newly composed function. So we look at our inner function, m of x, 2x plus 1, no domain restrictions. Now look at your newly composed function, h of m of x, no new domain restrictions. So the domain here is all real numbers. Interval notation, you can plug in from -infinity to infinity. So now, what if I evaluate f of g of x and state domain of result? So I have to stick g into f everywhere that there is an x in f. So there's only an x right here. So that's going to be 1 over the square root of x minus 1. And so now we shouldn't have a radical sitting in the denominator of our fraction. So let's rationalize that. So we need to multiply it by the square root of x minus 1. That's going to leave us with the square root of x minus 1 over, this is going to be the square root of x minus 1 squared, which is just x minus 1. And now, this is f of g of x. the square root of x minus 1 over x minus 1. Now, for domain restrictions, we look at g of x, where x first filtered through. So that was, for the domain, okay, that was the square root of x minus 1. So we need to make sure that we don't put any numbers in that could give us something that's not real. So since it's a square root, we already know. We take the radicand, has to be greater than or equal to 0. That's going to be x has to be greater than or equal to 1. Okay? And now we check two places, right? We check g of x, and then we check the new function we get. So this is the check of g of x. Now we need to check f of g of x, our new function. So remember, domain restrictions, we don't want to take square roots of negatives. And remember, another type of domain restriction is going to be what is known as an undefined value. A number is undefined if its denominator has a value of 0. So we have a fraction. We have a rational expression. F of g of x is a rational expression. It's written as a ratio, the square root of x minus 1 over x minus 1. Therefore, we are concerned with making sure that the denominator, as long as there are variables in the denominator, you need to check and make sure, can any real number make the denominator 0? If it can, then you must restrict it out of the domain. So sitting in the denominator is x minus 1. That cannot be 0. So what number makes that 0? 1. Therefore, 1 is not allowed in the domain because 1 is going to make f of g of x have a denominator of 0. Not good. So the domain of this function, we have to combine these two. So x has to be greater than or equal to 1, but x also can't be 1. Therefore, x has to be greater than 1. If you write that in interval notation, parenthesis 1, infinity, parenthesis. And last, what if I asked you to evaluate, oh, I didn't mean evaluate. Oh, in these problems, I didn't mean to write evaluate here. Cross that out. Cross that out. You are not evaluating. You are just finding your new function. And in number 3, we're going to evaluate m of h of g of 5. So here, you're actually getting a value. If you notice, the input of x got replaced with the number 5. So we actually want to know, okay, we have a new function, m of h of g of 5, and we need to figure out what the output is going to be. So the first thing we do is, okay, we should plug 5 into g. G of 5 is going to be the square root of 5 minus 1. That's going to be the square root of 4. The square root of 4 is 2. So g of 5 is 2. So g of 5 gets replaced with 2. M of h of 2. So now we need to find what h of 2 is. H of 2 is going to be 2 squared plus 5 times 2. So that's going to be 4 plus 10. That's going to be 14. So h of 2 is 14. So m of 14 is what we need to evaluate. So that's going to be 2 times 14 plus 1. That's going to be 28 plus 1. That's going to be 29. So m of h of g of 5 evaluates to be 29. So in the next video, what we're going to do is we're going to do function composition, but we're going to do it where the functions that you are making your composition with have a specific restricted domain.